Hello there, and welcome back for the final Punnett square problem. And this one is a problem. This is difficult, so just hang with me. If you're not real comfortable with the first two videos, I would probably watch those again before watching this one, because this one is a little bit more of a challenge. Not that the first two weren't, but this is a tough problem in my opinion. Okay, this is page 75 in the work text. And it is a Punnett square problem that I made up just to help you understand some terms and some concepts that we really need to hit home. So here we go. It says a man with AB blood and a woman with heterozygous type B have a child. What is the probability that the child would be homozygous type B? So the first thing that you need to understand to do this problem is about the blood type system. So in human blood, you can have three basic types. You can have type A, you can have type B, or you can have type O. Now you can be A positive, A negative. We're not going to get into that today, because that's a little bit more than what I want to do right now. But you have three basic types. And what I want to show you is that A and B are both dominant. So they're both capital letters. And O is recessive. So let's just review a little bit before we get into our problem. We're not even looking at that yet. I'm going to give you some genotypes. And I want you to help me figure out the phenotype, where blood problems are related. So let's make ourselves a little table. That'll be a little bit easier. So let's say that this person has this type of blood, A and O. What type of blood would that person need at the hospital? Because you can't give them both. If you give the wrong type, you can kill someone. Okay, A is dominant, O is recessive, so that person is going to need type A. What if a person has this type? Okay, they have type B, dominant, O recessive, B dominates, so that person would need type B. What if the person comes in with this type as a genotype, where mom gave them O, dad gave them O? It's pretty clear on this one, that person would need type O blood. But what happens when mom gave you A and dad gave you B, where both of the letters are capital letters? So this is called co-dominance, where you have both alleles that are dominant. So what kind of blood would you give this person if he or she was in surgery and needed blood? Well, you can't give them O because B is dominant too. I'm sorry, you can't give them A because B is dominant too. You can't give them B because A is dominant also. So you would give them AB. You would have to give them blood that matched exactly what they needed. So understanding the different types of blood is important to understanding this question. Okay, another thing that's important to understanding this question is the difference between homozygous and heterozygous. So let's just look at these genotypes and figure out which is which. Okay, the first person has AO on the alleles. That is hetero because they don't match. So that's a heterozygous genotype. Same with the second. You've got a B and an O, that is heterozygous genotype. They do not match. When they match, like this one, that's called a homozygous genotype. And then this one, of course, is hetero because A and B do not match. They're different letters. Okay, so let's try to understand this question. A man with AB blood. So they were nice to me right there. They just went ahead and told me what that means. And a woman with heterozygous type B. Okay. Have a child. What is the probability that the child would be homozygous type B? So the man, we're going to use, I'm just going to put him on the top here. It doesn't matter. You can put either parent on either side. So here's so the man has AB. They tell me that right off the bat. That's heterozygous, but it is codominant heterozygous because both of those are equally dominant when you're talking about dominant and recessive. So here's the man. They tell us that he is AB. The woman is heterozygous B. So we know she has B, and we know that this can't be another B because she would not be heterozygous. If we made this another A, that would be codominant. So I'm inferring that she has the dominant B and the little O. Okay? I'm going to see B blood with her, but she's carrying that O also. So then we do our crossing. We're going to say here is A, B, here is B, B, here is A, O, and here is B, O. And our question says, what is the probability, what is the chance that the child would be homozygous type B? Okay, so let's look here. This one is not B. That one is AB. They're codominant AB. This one would be A is dominant, so that child would have type A blood. This one, B is dominant, so the child would have type B. But the question says homozygous type B. This is heterozygous type B. This is homozygous type B. So the one I'm looking for is right here. And there's only one of those. So the probability is 1 out of 4, or 25%. So the probability that the child is homozygous type B is 1/4, or 25%.